Hello everyone. Hope everyone's having a wonderful Wednesday. Right now, everyone should have their notes out, pencil, paper, all that good stuff. We're going to take some notes to begin with. Now, first off, this says use the distributive property to factor 15x plus 25x squared. Okay? The very first thing that you should do is what it says. First, find the greatest common factor of these numbers. Now, we've already done that before, so we need to completely factor out our two numbers. So what we're going to do first, we're going to completely factor out our two numbers. Now, 15x, if you factor that out, it would be 5 times 3. That gives me 15. What do I have left? I have an x left. So 15x is completely factored. Now let's go and completely factor 25x squared. Now, we know that 5 times 5 gives me 25. I have an x squared left. So that is just plain out and simple, x times x. Okay? So right now we have completely factored our two numbers. Okay? Now, let's find the greatest common factor. So, remember how to do this. We factored our two numbers out. Now we need to circle which numbers we have in common. What are my common prime numbers? All they are is 5 and x. Okay? So when you go to write that, our GCF is 5x. Okay? Now, use the distributive property to factor out the greatest common factor. What it means by that is, whatever terms are left for our two numbers, what I mean by that is, look at my terms in blue. Okay? I have a 3 and also, so for my 15x, all I have left is 3. That's my remaining term. Okay? So, our greatest common factor is 5x. So essentially, if I multiplied 5x times 3, I get 15x. Is everybody following me? If I distribute that out, that'd give me 15x. Now, let's work with our 25x squared. Let's find our remaining terms. I have a 5 and I have an x. Okay? So, just like we did before, if we multiplied 5x times our remaining 5x, we get 25x squared. Is everybody following me? Now, to write this correctly, one more thing we need to do. We need to write it so that our greatest common factor is on the outside, and our numbers of 3 plus 5x are on the inside. Now this would be completely factored in terms of using the distributive property. Okay? Because look what happens if a great way to see if you did this correctly is to check it. If we multiplied 5x times 3, we'd get 15x. Look up at the top right. We'd get 15x. If we multiplied 5x times 5x at the bottom, that gives you a plus 25x squared. The same exact thing as we started out with. So your answer would be what we did here at the bottom. Okay? That is our answer right there. I'm going to kind of square it with green. So that would be our answer. This is what I want you to do. Okay? Now, I promise this will make more sense as we continue working. So be patient. So let me just run through our steps again one more time. All right, so first you need to find the greatest common factor. So that means factoring out both of our terms. All right. So we factored out our 15x to begin with, and then we factored out our 25x squared. Then we found our greatest common factor, which is in red. We figured out that our GCF is 5x. Okay? Now, to use the distributive property of factor, all we did was wrote our greatest common factor times whatever we had left for our term. For 15x, look at our blue. 3 was the only term we had left, so we just put that in parentheses and multiplied it right there. Same thing for our 25x squared. We had 5x in purple. That's all the remaining terms that we had. So all we did was write 5x right here times our greatest common factor of 5x. Now to put it all together, you have your 5x, which is our greatest common factor, on the outside. And whatever terms you have here of 3 and 5x, you just put it inside the parentheses. And then lastly, to check your answer, so our answer is in green. To check our answer, if you distribute this out, 5 times 3x, you get 15x. If you did 5x times 5x, you get 25x squared. Okay? How cool is that? All right. Now, this is the same thing. We're using the distributive property of factor. Now, this is a, if you guys remember correctly, trinomial, because I have 3 terms. Okay? Now, we're going to do this the exact same way we did the first one. The only difference is we just have another term. So they're just asking us to work a little bit harder. All right? Now, so we need to do the same thing. We need to factor out each term. Now, if you guys are understanding this, go ahead and move on. Then as I finish, you can check your answer. All right. So to factor out this term, I know I can do 6 times 2. Okay. Now, can we factor out 6? Yeah. We can turn that into 3 times 2. Okay. So we can factor out 6, and we can get 3 times 2. Now, I'm going to erase that so I can just write it neatly. So we just found out that we can go 3 times 2 times 2. And to check your answer, multiply 3 times 2, you get 6. Multiply it times 2 again, you get 12. Let's factor out our x and our y. Okay. Now let's move on to our second term. Now, we can do this one in, let's go 2 times 12. Let's factor out our 12 again. We have 6 times 2. Okay. Now we need to factor out that 6 again to 3 times 2. So the numbers that we need to have in our factored form are 3, or 2, and another 2. Now we already have that original 2 up there, so we got 3, 2, 2. Okay, so I'm going to erase this and write this neatly. Now remember, always check your answer. 2 times 3 gives me 6. 6 times 2 gives me 12. And then 12 times 2 gives me 24. Now it's pretty simple to factor out the variables. If I just have one x, I just got one x. If I got a y squared, I got two y's. Alrighty then. Now, remember, this is a negative 30 x squared and y to the fourth. Okay. Okay, so remember, to factor out a negative number, we need to factor out that negative 1, and then we just need to factor out 30. Okay, so that's going to be 15 and 2. It's going to be 15 and 2. Let's factor out that 15 to 5 and 3. Okay, does everybody see that? Now I'm going to erase that 5 and 3 below. I'm going to write it up top. So I had a 5, and I'm going to write that 3 over here. Now, check your answer again. Let's check it. If I multiply negative 1 times 5, I get negative 5. Negative 5 times 2 gives me negative 10. Negative 10 times 3 gives me negative 30. Bingo. All right. Now, factor out your variables. I got an x squared, so we're doing 2x's. Now move on to your y's. If I got a y to the fourth power, how many y's am I going to have? You guys can say it out loud. 4. Awesome. Okay. Now, let's find our GCF, greatest common factor. And how do we do that? We circle our common prime factors. Okay, so I have a 3, a 3, and a 3. Now I'm not going to circle, I'm just going to mark through, I'm just going to dash. Okay, hopefully that won't confuse you too much. Okay, now I have a 2, a 2, and a 2. Kind of like a 2-2, but a 2-2-2. Alright, now that looks like all of my coefficients or my numbers, that's it. Okay, now let's move on to our x's and our y's. Looks like I have an x, an x, and an x. And it looks like I have a y, and a y. So, let's go back to this. I have a 3, I have a 2, I have an x, and it looks like all I have left is a y. Now go ahead and check back. Looks like it's it. Okay, so combine those terms, that gives you a 6xy. Okay, okie dokie. Now, this is our greatest common factor, our GCF, 6xy. So, now we need to determine what our remaining terms are. So, looks all I have left is a 2 up top. Okay. Now, for my middle term, all I have is a 2 and a 2, and then also I have left is a y. Okay. Lastly, I have a negative 1 and a 5, and then also I have an x, and also I have 3 little old y's at the end. Okay, so let's put these terms together. For my first term, it's going to be in blue. All I have left is a 2. For my second term, which is in purple, all I have left is a 2 times 2 and a y. Now 2 times 2 gives me 4, so that leaves me with a 4y. And then lastly, I have a negative 1 times 5, so that's going to give me a negative 5. And I have an x, and I have 3 y's, so I'm just going to put y to the third. Okay? Awesome. All right. Now, we need to distribute these terms. All right, we need to put these terms together. So, remember what leaves off. What leads off is my greatest common factor, so I'm just going to write that 6xy. Okay? Now, the really easy way to do this is to write now, if this is a positive 2, I'm just going to write it as just 2. If that's a positive 4y, all I'm going to do is a plus 4y. And lastly, if this is a negative 5x and y to the third, I keep that negative in front of it, and I write my 5xy to the third. Okay? That's all I'm doing. This would be your complete answer. Okay? That right there is your final answer. See what we did? Now remember, you can always go back and check. And how do we check? Hence the name distribute. We can distribute this term. Do that times that. And if you did that, you would get your exact same expression was what we started out with. You get this exact same term, or terms if you want to say. Okay? So, kind of rewind. We started out. We factored our terms out, each one. Okay, factored all these out. Next, we found our GCF. We had all of our like terms. We had 3's in common, we had 2's in common, and lastly, we had x and y in common, right? Next, we figured out our remaining terms. Whatever's left, you write to the side. That's a 2. I had a 2 times 2, and I had a 4y. For here, I had a negative 1 times 5, an x, and 3 y's. So I just combined those terms, and this is what I got. Now, to finish it all off is put your greatest common factor outside the parentheses, or lead off with it. Everything that you have figured out, your 2, your 4y, your negative 5xy to the third, you put it inside the parentheses and keep this sign in front of it. Notice I had positive here, positive here. Oops, I had a negative here. Just put a minus. That's all you got to do. Okay? Now, I know you guys are having so much fun right now, and I hate that I'm missing it in person, but I'm glad I get to somewhat be with you, if you know what I mean. And also, guys, if you get bored on your free time, don't forget to Google me, YouTube me, okay? I'm trying to get my views up, and I need your guys' help. All right. Now we're done with factoring with distributive property. Now we're going to factor by grouping, okay? So take 1 second and copy this down. As you guys are writing, I'll wait. As you guys are writing, give you time to write this down. If you need to, you can pause the video. So that everybody gets this down, and then I'm gonna talk about it and explain it. So you can go ahead and pause the video. Okay. Let's talk about this for a minute. Let's chat. Alrighty-o. Now, we started out with this factor 2xy plus 7x minus 2y minus 7. Okay, this was our original equation. Okay. Your first step is to group terms with common factors. Does everybody see that? That should be your very first step, is group terms with common factors. That's what they did here. Look how they grouped the 2xy and the minus 2y. Now, first of all, they kept the sign in front of it, whatever it may be. Okay? Secondly, they noticed that I got a 2 here and a 2 here. Okay, we know we can at least factor a 2 out of there. We know we can at least do that. Okay? Secondly, they combined, or they grouped the terms of 7x and negative 7 together. Does everybody see that? They got a 7x and then minus 7. They kept the sign in front of it. And they just put it together. That's all they did. All right? Next, they factor the greatest common factor from each grouping. Now, what they mean by that is they went ahead and factored their two terms. Let's look at the first term. Okay, they factored out the 2xy minus 2y. Let's just look at this. Do not look at anything else except this first one. Okay? So they found that the greatest, so if they over to the side, if you want to factor these two numbers out, you can do that. All right? And they found out that 2y is the GCF, greatest common factor, of just those two terms. Okay, just those two. Now you can always go back and check by distributing this out. If you distribute this out, you come up with your original terms right here. Okay? Secondly, let's look at our second terms. Now all they did was found the GCF of these two terms. You can kind of just look at it and say, okay, looks like 7's going to be the GCF. So they had that outside the parentheses, and they had whatever they had left, their terms left, inside the parentheses. Okay? Does everybody see that? Now notice, look what we have in green. We have the same exact thing. I got an x minus 1 here, I got an x minus 1 here. Okay? So, to factor by grouping, this is what you're doing. You're grouping your like terms. You're grouping your terms with common factors. So they had an x minus 1 here. That's what they had in green. And secondly, they had their GCFs, or whatever's in red, in our second thing. Okay? So I had a 2y here, so I put 2y. I had a 7 here, so all I did is put 7 here. And this is how you factor by grouping. That'd be your answer. This is your answer. X minus 1 and 2y plus 7. All right? If you're like, what in the world is Mr. Schwab talking about on his iPad? We're going to talk about it. Okay? We'll practice. Practice makes perfect. All right? Now, if you need to, you can rewind the video and kind of run through it just like I did. The more you go through it, the more it'll make sense. I think you guys are some smart kids, so I think you'll get it anyway. Don't worry about it. Okay, guys. Had a little technical difficulties right there. Hopefully this is the same problem that we continued. If not, just worry about this one right now. So we're going to do the same thing. We're going to factor by grouping. Now for here, we need to group together our terms with common factors. Now if you look at this, looks like it's already grouped together. It looks like if I have 2mk and 12m, looks like I can factor out a 2 from there, and maybe an m. Now if we look at our other terms of 42 and 7k, looks like I can factor out a 7 from there. Okay, so I'm grouping together my common factors. Now, we need to find the GCF from each group. Now, when you do this, you can do it on the side or wherever you want, or you can kind of do it mentally. Okay? Because I think we've practiced so much with it, I think you guys can kind of catch on and do it mentally. But if not, you can take the time, factor each one out, then circle our like terms, okay, which gives you the GCF. Alright, now if I do this one, I'm going to do my first one. Looks like my greatest common factor is going to be 2m. Okay, because I can factor out a 2 and I can factor out a m from those two terms. What I have left is a k minus a 6. Okay? And remember, you can always check by just actually distributing this out. Okay? You can distribute both those terms out. It's going to give you the same exact answer up top. Right? So don't worry about that. Now when it comes to this, you're going to do the same thing. Find your GCF, your greatest common factor. Alright? Now it looks like all you can factor out is a 7. Okay? So, looks like my GCF for these terms is a 7. Okay? I'd have a 6 right here and a K right here. Okay? Now, if you need to, like I said, you can factor those two terms out, circle your greatest common factor, and then you'll find that all you have left is a 6 and a K. Alright? You'll see that. Okay, so you can do it either way. Now, when it comes to, notice how I have K minus 6 right here. Okay. And over here, I have 6 minus K. Okay. We need these terms to essentially flip. We need to flip this K and this 6. Anytime you have a situation like this, you essentially need to almost factor out a -1. Okay, what I mean by that is, whenever you have a situation where your variable minus or plus, whatever that term is not the same, okay, like I said, we have a K minus 6 right here, and then I have a 6 minus K. That's not the same. You can't just flip that, because if you just flip that, that'd give you a -K plus 6. Do you see that? So we have to make that right. What I mean by that is, you essentially need to factor out a -1. So over here on my left, it's going to stay the same. Okay, I'm just going to rewrite that. Ooh. Okay, that's going to stay the same. For this, you need to factor out a -1. Okay? That's what you're doing. And then what you have left, once you do that, you can flip that K minus 6 to where we need it to be. What happens when you multiply 7 times -1? You essentially get a -7. Okay? So you can really think about it in terms of whatever that term is in front of it. Notice that my 7, you can think of it as, I need to, if my terms don't match up, if my K minus 6 does not match up right here, you can just think of it as, okay, I need to make this term a negative number. Okay, or you need to factor out a -1, because if it's a positive to begin with, it becomes negative. But if it's a negative to begin with, it becomes positive. Okay. So all I did essentially was change the sign of this 7. This positive 7 becomes a -7. Okay. And now look what we have. We have K minus 6 and we have K minus 6. So now we can factor by grouping. Okay. So your correct answer for this would be, I would combine my 2m and my -7. I would group that together. And then when I would have my K minus 6. That would be your answer for this one. Okay? So it's similar to our ones we started out with by factor by grouping. This one kind of gives you a curveball. All right? It'll make more sense after I do one more, I promise. All right, so get this down, pause it if you need to, because I'm about getting ready to clear it. Okay. Now this is the same kind of problem that we just did, so if you want to, you guys can go ahead and try to work it out. Now we're doing the same exact thing. We're gonna group our terms together that have common factors. Okay, now it's already grouped for you. Notice that all I have is I got a C minus a 2CD. Looks like right off the bat I can just factor out a C from there. Okay. Over here I have 8D minus 4. Okay, looks like I can factor out a 4 from there. Are you guys seeing how I'm noticing? Now these numbers are pretty small, so you really don't have to, I guess, think about them too hard. Now if there were some larger numbers, you'd have to kind of factor out each term and circle your common factors. You guys can still do that. Does not matter, whichever way works for you. Okay, now looks like this first one, my greatest common factor is just going to be flat out C. Okay, that's all I can factor out of there. Now what I have left would be a 1, because C times 1 gives me C, minus a 2D. Okay, now remember, you can always check it by distributing that C. If I multiply C times 1, I get C. If I multiply C times a negative 2D, all you're doing is adding a C to that. Okay. Now for this, looks like I can factor out a 4 from here. Now if I do that, so 4 would be my greatest common factor for these two terms. What I have left would be a 2D and B minus 1. Okay. Now here we go again. Look at my terms in parentheses. They do not match up. But all I need to do is essentially flip them and change their signs. Okay? So you can think about it like that. You could flip this and change all these signs, or you can essentially, what you're doing is factoring out a negative 1. And it's kind of your rule that you can use for this. All right. So I'm gonna work it out with. I'm gonna write the same thing over here because I'm not messing with this side. Now over here, this is where I'm getting that negative 1 out of there. Okay, it's called an additive inverse, if you want to know the actual terminology of it. So when you do that, that negative 1 becomes a positive 1, and you can kind of flip it. This 2D to begin with becomes a negative 2D. Okay? Now, this positive 4 right here becomes a negative 4. And all this stays the same. Okay? Now we are factor by grouping right here. Look at this. We have the 1 minus 2D, and I got a 1 minus 2D. Now let's put our terms together. Let's combine them right here. So I have a C minus 4, and I have a 1 minus 2D. This is your answer. Okay? That's a C right there. Sorry. That's your answer. Does everybody see how we do that? Pretty cool, huh? I hope everybody's having a good day so far. Now, okay. Now, I want you guys to turn to page 480. Now, you're going to be doing numbers 15 through 38. Okay? That sounds like a lot, but I promise you guys will do very well with it. Now, 15 through 20. Okay? Read those directions. You can pause the video if you need to. That way everybody gets to this page. Read those directions. 15 through 20. Use the distributive property to factor each polynomial. Now, all you're doing there is factoring those two terms. Now, if you want to flip back to page 476. So 15 through 20. Look at page 476. Okay? Because that's very helpful. Now, we've already did a couple of those together. So you can look through your notes, or you can look at that example on page 476, those two examples of A and B. Okay? So first, you're finding the greatest common factor. And then whatever terms you have left, look how all they did was just put it beside of it. That's what we did at the very beginning of this. Okay, whatever you have left, you just leave it there. All right. Now, for numbers 21 through 38, that's what we just got done doing. Okay, we're factoring each polynomial. Now, this is where we're factoring by grouping. Okay, that's what we just got done with. All right. Now you can look at page 477 to kind of help you out. And then also you can look at you can look through your notes. Whichever you want, whichever way you want to do it, doesn't matter to me. Okay, because there's some really helpful examples on both those pages. And then also look through your notes. Okay, that'll help you out also. All right. That is all I have for today. I look forward to being back Friday. Now Thursday will be similar to this, and I'll kind of figure out how far you guys got through with this work and how you guys are doing. So have fun, and I will see you guys later. Bye-bye.